about two different sections, okay? Now, the reason we're going to cover two different sections at one time is because they're basically the same rules, okay? The same rules apply to them, to multiplying and dividing in both cases. However, they are not the same as adding or subtracting, so it's going to be very important that you keep the two separate, okay? For multiplication and division, for multiplying and dividing, okay, the rules are these. Obviously, when you multiply or divide two positives, okay, when you multiply two positives together or when you divide two positives together, obviously we've been doing this since, first kindergarten, whenever, that's always going to be equal to a positive. Okay? Now, when we have two negatives and we're multiplying, or two negatives and we're dividing, that is always going to be equal to a positive. Okay, so that's the one that's different, one of them. Okay, when you're adding two negatives, you always get a negative answer. Okay, when we're multiplying negatives or dividing negatives, you always get a positive answer. The only time that you're going to get a negative answer when you're multiplying or dividing is when you have the third scenario of the only time you're going to get a negative answer is when you have one negative sign and you're multiplying or dividing. It does not matter which number's larger. Okay? For example, if I have negative 3 times 60, okay, negative 3 times 60 is going to give me negative 180. Just as negative 60 times 3 is equal to negative 180. And it doesn't matter which one comes first, doesn't matter which one comes second. It matters if there's one negative sign, the answer is going to be negative. If there's two negative signs, it's positive. If there's two positives, it's positive. Okay? Now, one of the ways they're going to show division is they're going to do this. Negative 60 over 2. Okay, that is a division problem. Okay, remember, this is the same thing as that right there. Okay, which we know and understand is that's the same thing as that. Okay, the negative sign doesn't have any bearing on what we do with the problem itself. We're still dividing 2 into 60. 2 goes into 60 30 times, but I have a negative sign, one negative sign, so it's negative 30. So each one of these would be negative 30. Doesn't matter which way they express it, obviously they have that sign right there. Now, the answer doesn't change if I have this. 60 divided by negative 2. Okay, it's still negative 30. Doesn't matter if it's on top or if it's on bottom, if it's second number, first number, none of that matters. Doesn't matter the size of the number. The only thing that matters is I have one negative sign. It means it is a negative answer every single time. Okay? Any questions on that before I move on to more examples? Okay, now, let's look at a problem like this. Let's say I had 3 times negative 4 times 5 times negative 6. Okay? Well, because of the associative property of multiplication basically tells us that we can only multiply or add two numbers at one time. Okay? Now, we can probably multiply this together fairly quickly, but I can't take 3 times 4 times 5 times 6 and do it all at once. Okay, there's some, I'm sure, mathematicians that could, give you that problem and a second later give you the answer, and obviously they're not multiplying all the numbers at once, so you have to multiply them out. Now, the associative property says I can multiply those two together first, I can multiply these two together first. It doesn't matter which ones I multiply together first, I will still get the same answer. Okay, but for our purposes, I want to look at this. Okay, now 3 times negative 4, hopefully it's going to catch up to me. Three times negative 4 is negative 12 because there's one negative sign. Okay, now I rewrite the problem. So what is negative 12 times positive 5? Negative 60. Okay, now I have negative 60 times negative 6. Okay, now here's where it's different. Okay, positive 360. Because when you multiply two negatives, you get a positive answer. Okay? The other rule that we can have here is this. When there is an even number of negative signs, it is a positive answer. Now, this only applies to multiplication and division. When there is an even number of negative signs, in other words, I count the number of negative signs in this problem, 1, 2. So there's 2 negatives. Okay? 2 negatives would be equal to a positive. Okay? Now, the inverse of that, when there is an odd number of negative signs, the answer is negative. Okay, it'll show up here. It's running behind for some reason today. Don't really know why. And that's why, because I'm on the wrong router. See if it'll show up now. Okay, when there's an odd number of negative signs. So, I'll do the same problem. And let's say we had negative 3 times negative 4 times 5 times negative 6. Now, in this problem, we have 3 negative signs. So, I really don't even have to know anything, but I have 3 negative signs, and it's all multiplication. Okay, that's one of the first keys. You can't have a mixture of multiplication and addition and still use this rule. It has to be either all multiplication, all division. If there's an odd number of negative signs, which 3 is an odd number, okay, then it's going to be a negative answer. I will prove that mathematically by doing this. Negative 3 times negative 4 is a positive 12 times 5 times negative 6. Positive 12 times 5 is a positive 60 times negative 6. 60 times negative 6 negative 360. Okay, so I proved it to you mathematically by our original rule of 2 negatives make a positive, 1 negative makes a negative. So here we had 2 negatives yielding a positive 12. Positive times a positive yields a positive 60. Positive times a negative equals a negative 360. Okay, but I already knew it was going to be negative simply because I counted up the number of negative signs in the problem and knew that there was an odd number of negative signs. Now, if I did it one step further, let's say I said negative 3 times negative 4 times negative 5 times negative 6. So how many negative signs are there? Is that even or odd? That's even, last time I checked. So that's just a positive 360. And that would be your answer. Celine? Can you put a positive sign? You can if you would like, but it's not needed. And make sure there's not other numbers around it so that somebody doesn't think it's, adding. If I was going to put a positive sign, I'd put it up here at the top of the number, not in front of the number. Okay? Now, let's talk about mean. Not somebody that is mean, but mean. As in mean, mode, range, all that stuff. All right. Let's say I gave you these numbers. Negative 46, negative 33, 0, and 11. And I want you to find the mean of this data. Obviously, we know that the mean is the average. Okay? Now, this is where it gets a little bit challenging, just simply because you're tempted to follow one set of rules when you're going to have two set of rules in play here. Okay? The first set of rules that we're going to have to do is to find the mean or the average. What do we do first? You add the numbers. Okay? So, the first thing I have to do then is take negative 46 plus negative 33 plus 0 plus 11. And this is where you will get confused. It happens every year. Doesn't happen to everybody, but some people it does. You'll get here and you'll go, well, Coach just spent 10 minutes talking about when you multiply two negatives together, I get a positive. And so somebody will tell me that that's going to be a positive 79. Okay? This right here is a negative 79. Because why? When you add two negatives, you get a negative answer. When I take $46 from you and then come back the next day and take $33 from you, there's no way you're going to be positive about that. If you are, let me know and we'll start it tomorrow and do that. Okay? So, Drew, bring your $46 tomorrow and I'll take it from you and you can be happy and joyful, and then the next day bring your $33 and I'll take that from you. Okay? So, for the most part, most of us are not going to be happy about losing $79. Okay? Now, if we finish the problem out, obviously when we take 0 and add it to any number, that number stays the same. So you have negative 79 plus 11. Now we further are going to confuse things here because we have a negative and a positive. We have to take the absolute value of the two numbers and subtract their absolute values. Okay, it's what we covered in 6.2 and 6.3. Okay, 79 minus 11 is what? 68. Now, the larger absolute value is negative, so I have to bring it down into my answer. Now, I'm not done. Okay, I'm not done because I'm looking for the average. Okay. If I look at these numbers up here, there's no way that negative 68 could be the average of those numbers, because negative 68 is smaller than the smallest number I have up there. So what we have to do then is we have to take and divide negative 68 by the number of numbers that I have, which is 4. Okay? You divide 4 into 68, you get 17, but I have one negative sign. See, there's no way that it could be 17 either, because 17 is larger than my largest number that was given. And so it has to be negative 17 because of that one negative sign. I have to bring it down into the answer. So the average or the mean of that data is negative 17. You can have averages that are negatives. Okay, you can have averages that are negative in decimal. Because you think of, for example, if you think of the average low temperature in Alaska, okay, the average low temperature in Alaska is probably not a positive number, if I had to guess. Okay, now I don't know what it is, but I would assume that if you lived in Alaska, where there's always snow and there's always ice, and it's always present, that you don't get above freezing that often. Okay, now I know there are times in the afternoon maybe they do, okay, in this, what they would call the summer, okay. But there again, I'm not sure which season it is for them, but either the summer or the winter, you know, is when they have mostly night and they don't have sunlight. They go through periods where, you know, 23 and a half hours of the day are dark. Okay, and they actually go through days where they have multiple days in a row that are just, you never see the sun. So, all right, so that's how we find mean or average for negative integers. Okay, some of the ones you're going to have to do are obviously, you're going to have to do some of those. All right, let's look at some more, just a couple of more examples. Remember this, if you have 10 times 0 times negative 7, okay, the same properties that we've learned before apply here, okay? It doesn't matter whether you're dealing with positive or negative numbers. Anytime you multiply something by 0, it's still 0. Okay, so the answer to this problem is 0. Okay, now let's also remember that 0 is neither negative or positive. So don't put a sign in front of 0. 0 is just 0. 0 is an integer. Okay, 0 is an integer, Joshua. Let's try not to stab people in the back with a pencil. Okay. Now, remember, 0 is an integer, but it's not negative or positive, okay? Because integers include counting numbers that are negative, positive, and 0. Celine?
So anytime we multiply by 0, it's going to be 0?
Right. Doesn't matter if I have 20 numbers up there or just 2 numbers. If you're multiplying by 0 at any point in the problem, it's going to be 0 as the answer, okay? All right, let's look at this one. B to the 4th power, where B is equal to negative 2. Okay, so they want us to plug in the value for B to be negative 2. Well, that means I have this right here, negative 2 raised to the 4th power, which if we write that out in expanded form is negative 2 okay. Now this is one place where you can use that other rule that we talked about if there's an even number of negative signs or if there's an odd number of negative signs. Okay, if there's an even number of negative signs, 1, 2, 3, 4, that would be even. then my answer is going to be positive. I don't have to worry about anything. I just multiply it out, and it's positive. Okay? Now, if that was b to the third power, like that, then, of course, that would be negative 2 raised to the third power, which is negative 2 times negative 2 times negative 2. Now, I have to evaluate these. Remember the word evaluate. Talked about it, I think, in Chapter 1. The word evaluate means that we substitute in something and then we simplify it. Okay? Well, this would be substituting. This would be your substitution. Okay, this is the process. And then to simplify that, you would get, 16. And that would be simplified. Oh, yeah, simplified. Okay, so when they tell you to evaluate, they tell you to evaluate for the given values of the variables. Okay, evaluate, once again, is substitution, then doing your process of after substitution, and then simplified, taking it to its lowest terms. You cannot write this or this as your answer. That is not correct. Okay? That is not correct. The only correct answer to this would be the 16. Over here, b to the third, where negative 2 is raised to the third power, then this would be negative 8. The reason it's negative 8 is because we have an odd number of negative signs. We have 3 negative signs, so therefore that makes it an odd number, which in turn we're going to make that a negative answer. Okay? Now, with division, it's fairly simplistic because usually they're only going to give you 2 numbers to divide. In other words, most of the time they're not going to do this. They're not going to take negative 20 divided by negative 2 divided by 2. Usually they're not going to do that. Okay? So it's usually just in the multiplication where you're going to have more than 2 numbers that you're multiplying together at once. And the reason being for that is because there's no commutative property of division. There's no associative property of division. There is of multiplication and division. Now, understand the other thing is this. If I had this, negative 10 times 3 times negative 5. If I wanted to make this simpler on me, remember, we can use the commutative property of multiplication. Commutative property of multiplication says I can rearrange the terms or the factors in the problem and still get the same answer. So I can do this. Okay, I can put my 2 negatives together first. Well, negative 10 times negative 5 would be what? Positive what? Positive 50. Thank you, Emma. Positive 50 times a positive 3 is obviously going to give me 150. Okay? So we use the commutative property to put the negatives together. It doesn't matter which way you do it. In other words, if I just take the original problem, negative 10 times positive 3 is negative 30. Negative 30 times a negative 5 would give me a positive 150. Okay? Any questions over that? All right. Your homework is this. As I stated, we've covered 2 sections, so you're going to need to make sure you write it down because I'm giving you problems. Bless you. You might want to get your brain later. Because I think it just went out. All right. So from 6.4, you're doing these problems, 12 through 40 even, and number 41. 6.5, you're doing 12 through 28 even, and 36 through 42 all. Okay, obviously do that on one sheet of paper. You don't have to do it on 2 separate sheets. You got 6.4. I want to make sure that includes some of those mean problems that I talked about. Yes, hang on here. Let me do one other, let's look at one other thing. Everybody look at page 279. Before I stop here, look at page 279. Okay, at the bottom of page 279. At the bottom of the page, you see where it says to convert Celsius to Fahrenheit, use the formula F equals 9/5 times C plus 32. Okay, that's to convert Celsius to Fahrenheit. To convert Fahrenheit to Celsius, then the formula is this. Okay, now all you have to do is this. Let's say they give me a Celsius temperature, and these are just ones I'm coming up with here. Let's say they give me Celsius is equal to negative 20 degrees. Okay, and they want to know what that is in Fahrenheit. Okay, they want to know, so we're in Fahrenheit. That's what, when you see your temperature in your parents' car, it says 30 degrees, that's Fahrenheit. Okay, Celsius is used mainly in our country. Celsius is used in science, in the area of science. Okay, when they're talking about boiling points, things of that nature, they're going to talk more about Celsius than they are Fahrenheit. Fahrenheit's like our standard unit of measurements, yards, inches, feet, miles, okay, where everybody else uses metric system. That Fahrenheit's like our, I don't know why we do it this way, but we just got to be different. You know, Americans, they got to be different, so we're going to do it our way, okay? Most people use Celsius temperature, okay? We use Fahrenheit. So you need to know how to convert it, okay? All you have to do is this. We take this information and plug it into this formula. So that gives me Fahrenheit is equal to 9/5 times negative 20 over 1 plus 32. Okay? So now it just becomes multiplying negatives. Okay? I can cross cancel here. 5 goes into 5 once. 5 goes into that 4 times. Be negative. So what's negative 4 times 9? Negative 36 plus a positive 32. Okay? Negative 4. So the Fahrenheit temperature would be negative 4 degrees. So if it's negative 20 degrees Celsius, okay, it would be negative 4 degrees Fahrenheit. Okay? Now, if they give you the Fahrenheit temperature, let's say we say it's 42 degrees. Let's do this. Let's go 45 degrees. Let's say that Fahrenheit is equal to 45 degrees. Well, I take this and plug it in right there. Okay? And then simplify it from there. Okay, so you take 45 minus 32, and then you take it and multiply it by 5/9. Okay? Now, the ones they're going to give you in the book are going to come out to be whole numbers. That's why I don't like doing these in my head, because if I finish this one out, you're going to end up with basically this. You would have Celsius is equal to 5/9 times 45 minus 32, which is going to be 13. And you're going to have 5/9 times 13 over 1, which is 45, which is going to be, 65. 65 over 9, and so you're going to get a decimal number, okay? And the ones they're going to give you, you're not going to get a decimal number, okay? But that's how you would do it, okay? So I want to make sure you do that, because there are several of those problems, not many, I think there's 2 that you have to do there, okay? So go ahead and get to work. Still got 15 minutes left in class. You can get quite a few of those done, because they're not hard multiplication problems. They're like, 10 times negative 6. Oh, wow, negative 60. Okay, you must write the original problem. Okay, you must write the original problem, and then you can put your answer underneath it, because most of it you'll be able to do in your head. Okay, and it's fine to do it that way. Do what? I don't know when her off hour is. I think it's 4th hour and 7th hour or 6th hour. All right, so get to work.